with the Athena tutorials and move on to 3D Rayleigh-Taylor instability. To start with, we're going to browse our way over to Athena tutorial MHD. It's going to be this first link, princetonuniversity.github.io. I'm going to scroll down to documentation, click on tutorial, and then we're going to click on, I guess we're not on the 3D MHD yet. We'll take a look at this input file. Right, so if you want to configure, so let's take a look and compare what it's recommending this configure line with the previous one. I'm going to click on this 2D MHD Orszag Tang vortex. And so here it says configure with problem Orszag Tang with order 3. And it's actually the same thing. Oh, right, just editing the input file, changing grid resolution. Yeah, so maybe we'll run through this briefly. I think that we'll be able to get through this and get onto the Rayleigh-Taylor instability as well. So first of all, and I think the first video talked about how to set up an alias to do our SSH to a remote machine. I need to enter my 2FA and then my password. So just get my phone out and type that in. Now my regular password. Okay. And then we're going to go into Athena stuff, Athena, and bin. And I believe that I have the Athena input file here already. So it's saying to, make clean, configure, make all. Well, we just did that for the same configure line in the last part of the tutorial, so no reason to do that. And we also copied the Athena input file, from this source directory to our bin directory. And now we can edit it. And so, again, I talked about this very briefly last time, but in Athena, in the input file, there are these different blocks. So this is the comment block, where nothing inside this comment block affects how the problem runs. This config, I guess, is saying how to run this problem. So in order to do the configure line, you need --with--problem equal to Orszag-Tang. And then this is giving the reference for the problem, the authors for that journal, also the name of the problem. So none of this really matters. It's just kind of documentation. And there's the job block. So the problem ID gives the base name of the output file names as is commented here. So that's nice. Max out is the number of output blocks. So output 1, output 2, and output 3 are read for output equal to 3. If this was output equal to 2, only the first 2 would be read and the third one would be ignored. So this can cause some confusion. For example, if you have this set to 3, if I add a fourth output block, I get really confused and wonder why it ignored it. Num domains is similar to max out, but it's for the domain blocks, which is what we're going to have to deal with to change the resolution. And so again, we have these output blocks. They specify the output file format, as well as the DT, between which these files are outputted. And so this VTK file format is outputted every 0.004 time units, whereas the binary and the HST, or the history file format, are output 0.01, so a bit less frequently. Time block, we have the Courant number, which is the stability criterion. This always needs to be less than 1 unless you have a fully implicit code. N limit is the cycle limit, so the number of time steps that you take. TLIM is the maximum time in time units, in code units rather. And then we have this domain block, domain 1. I'm not sure if there is a second domain block. Kind of interesting. And then there's a problem block, which has the isothermal sound speed, which is 1 in code units. And then gamma, so this is for, an ideal gas, this is 5/3, which is written approximately here. All right, and then in the domain block, we have the level. So this is the root level, and then in the other domain block, we have the first refinement level. So at the root block, we have 192 zones in the x direction, 192 in the y direction, and then only one in the z, because this is a two-dimensional problem. And then we specify the minimum x value, the maximum x value, minimum y value, maximum y value, where we're using x2 as the y coordinate. And then the boundary conditions, which won't go over too much, but in general, boundary conditions might be periodic, like I believe in the Orszag Tang vortex. The boundary conditions are periodic. You can have reflecting boundary conditions. You can have outflow boundary conditions. There are a lot of different options. So this is saying that they do an extra level of refinement of additional 64 zones in a specific place in the compared to the root level. So for this, we're going to, it looks like they want to decrease the resolution, so that'll be nice because it'll make it run a little bit faster. So we're going to set this to 128, and then just want us to run it, so that's fine. So we can do that. This will go ahead and delete star VTK, go ahead and delete PNG, and delete bin. And although it's not specified in this tutorial, we'll do a little bit. We're going to keep that at the input file, remove the MP4 that we generated last time, we'll remove this history file as well. All right, so it's not, I think, the best practice, even though the tutorial is saying to do this, to do these runs in the binary folder. That's because it really makes everything a mess. If you're following along with the tutorials, you're going to have more and more files that end up just stuffed all in the same binary folder or bin folder. So instead, I like to make a runs folder, which I guess I already did. And let's see if they're, so I made some stuff previously, so I'll just remove them. And we'll make their Orszag Tang. And what is this thing called? We'll call it edited input file. All right, so we'll change directory into there, and we'll copy 1, 2, and then you can hit tab to kind of remind yourself which level you're at. So we need to go into the bin folder. The downside of hitting tab, so take a look, is it's typically not color-coded. There probably is a way to get it color-coded, but I'm not sure. And then we're just going to copy everything from there into our local directory, and I did not copy that images folder, which I forgot about, so I'm going to remove that now. So you want to be very careful when you do remove -r, because it will remove everything and everything lower. So if I do remove -r up 3 levels and do Athena 4.2, then I'll remove all of it, which is fine. You can always just download it again and re-gunzip it, re-untar it, but that's fine. Okay, and now we've modified our ath input file already, right? So we have our 128, 128. Okay, good. I wanted to check that Vim was remembering where we are, and it is. So we can do Athena-I ath input, and it will run, and it's running a bit faster than last time, or at least it should be, since there are fewer zones. And then this is saying, like, okay, you can change the resolution by modifying NX1, NX2. You can also add output blocks, kind of like what we did. So here they've edited it. So instead of the binary data dump, they do a VTK data dump. Sort of like what we did, where we replaced PPM with VTK. And then they also added a PPM. So they generate image files on the fly, which is nice, but I primarily work with Flash rather than Athena. So I don't know the nitty-gritty details of what the palette options are, or I don't know. In general, if you run like a code for a couple of days, you probably don't want to go back and rerun it for 72 hours every time you want to change color map, for example. So it's a little bit more useful to have VTK, or even better HDF5, or like other general output files that you can work with other applications to do the visualization and analysis after the fact. All right. And yeah, this is just saying if you change the number of output blocks, then you need to change that max out. Okay, and then, yeah, I don't think that will tweak. We already tweaked the output blocks, in fact, so we won't change that. All right, so we just ran this, and so we have all these VTKs. I guess I'll go ahead and get the script running again. So again, this plot script loops over them. We don't need this in parallel, so I'm going to remove that. And that means I also have to remove this yt.parallel objects, do just for fn and fs. So this is iterating over every element in this list, and so every element is assigned, this variable fn is assigned, each element in the list as it iterates. Another way of doing this basically is doing for I in range of len of f's. So range is also an iterator. Oops, I have one extra. And then you could say fn is f's of ii. But why do that when you can just do it, in fewer characters, which would be less typing if I wasn't showing you all how that works. All right, and then the other thing, so we don't have the first 32, so we might as well start from the beginning. All right, so I'm going to let that run, and that's going to take a while. And while it's running, we're going to look at the next tutorial. So that was the input file. Then there's also changing parameters through the command line interface. So right, I don't think I'd recommend. So yeah, sure, you can change the resolution by doing it in the command line, but you're not going to remember that you did that, and you do keep the input file around, so that's just a lot nicer, is to just do everything through the input file. And then, apparently there is Athena-H to get like a bunch of options. We'll take a look at that real quick. New tab, because I was asked recently, if you can do like Athena-H and get like different palette options for ppm, which I really don't know. Okay, so we'll go back to our runs Orszag Tang. I'm going to do /Athena-H. And yeah, it doesn't seem that useful to me. Input file -r restart. So this is useful for figuring out how to do a restart, which I haven't done before, but I'm sure it's not too bad. Okay, so you can parse the input file to see if there's an error or not without actually running it. That's probably useful for testing, for running like really big jobs. And yeah, so this doesn't really tell you that much as far as what options are available for the palettes for doing ppm outputs. But again, it's probably better to just do the plotting in Python or in post-processing. Okay. So that's simple enough. So we're going to move on to Rayleigh-Taylor instability. And so we'll go up here. And so that's the nice thing, is that, if we did the make clean, etc., while this thing is running, then I don't really know what happens if, we overwrite the binary file. Whereas now, up one more directory. And now we're in Athena 4.2 kind of root level. Now in bin, we can go ahead and remove everything from there, because I already copied everything to the runs/Orszag Tang folder. And now we can do make clean, do the configure with problem, go to RT with order 3, do make all, and we have to, as in previous videos, you have to set machine equal to Kraken, for example. Maybe at some point I'll figure out how to tweak that permanently. I know it's pretty easy in Flash, and I'm sure it's easy enough in Athena. I just don't know how to do it. All right, so what was the last command I did? I tried make all, so I try it again. And now it's compiling successfully. For some reason, they want you to modify this on the command line, I guess, just because it's an extension to the previous tutorial. I'm going to choose to not do that probably because I think that's kind of bad practice. So I'm going to cd into runs. I'm going to make dir Rayleigh-Taylor. Could call it RT, which is the, I guess we'll do RT since that's the extension for auth input. And then we're going to copy bin Athena into RT. We're going to change directory into RT. We're going to copy, go back to the root level of Athena. Just kind of have to keep that in mind, or if you don't remember where you are, okay, we're in the RT directory, up one level. That's the contents. That's not high enough. One more level, tab a couple of times, and that pops up the contents. You don't want to do this if there's, thousands of files. In that case, you just want to use ls pipe less or something like that. Or you can even vi the directory. Although again, that will take a while to load if there's a bajillion files. Okay, so we're up at this level. We want to go to tst 3d mhd at input. I'm using tab again to avoid typos. And then copy that to our local directory. So they always just, use the file. And so that's maybe to some extent why they're modifying it on the command line, is they want to leave what's in the test folder pristine. But I think it's better to just copy things locally and then play with them. So you'll learn a lot more that way. All right. And so they want to reduce the resolution, which probably makes sense because this is 3D. So reduce the resolution for NX1 to 32, NX2 to 32, and NX3 to 32, or wait, no, 64. Yeah, so the Rayleigh-Taylor instability is usually a box twice as tall as it is long or wide, so that makes sense. All right, and then the time block, we are going to change TLM from 6 to 3. So yeah, that'll really speed things up, which is nice, because otherwise 3D would take a long time on, just on a single processor. And so already this probably take a while. Yeah, it says 3,005 steps, and we're at like step 30 or so right now. So this is suggesting that this will take an hour to complete. Now, I mean, from the test, we're a factor of 2 to 5 times faster than them, so it should be anywhere from 30 minutes down to 12 minutes. But nevertheless, it's going to take a while. All right, and then they want to do an animate start at the, oh, we definitely don't want to do that. All right, so this thing is still plotting. I'm going to open another tab, SSH to the remote machine, cd into our folder, into runs, RT, and yeah, we are generating ppm, which I don't want. But we do have at least a few VTK. So let's take a look at the at input file. I should have looked at the output formats. So it's going to generate a VTK every 0.1. It generates the ppm every 20th of that. So let's just go ahead and kill this. So if you have a command that's running, you can kill it by doing Control-C, which generates this character. All right, so that's how to quit something in Bash, is you use Control-C, or probably, I think, every shell, but definitely in Bash, or in most Linux environments, I think. All right, so we're going to change at input, and we're just going to remove the ppm, or we're going to move the DT part over to the VTK. And then we're going to output the primitive variables. I guess we could just output the density, but might as well output some of the other variables as well in case we want to look at some other things. All right, and then we'll just change max out to 3. I don't think you need to do this, but might as well make it consistent. All right, and then we'll go ahead and remove RT star. And yeah, that looks good. So we're going to run that again. And so again, it's going to take a while. Is this thing almost done? Again, it ran out of memory. Unable to allocate 4.8 megabytes. That's not very big. So I think that there's a memory leak. And that's the downside about YT, is there are some memory leaks. Deprecated. Okay, it wants explicit f-type and f-name. That's too bad. It's really nice that it was doing that automatically. It's too bad that they're going to remove it. But oh well. So here's the traceback. It's pretty huge. So it happened when I was trying to save it. And it worked fine for the previous, however many of them it did. Let's see. Worked fine for the previous 204. I don't know why I had a problem for the 205th, except for that. I mean, kind of must have been that there's some memory leak in here. And so you can help out Python/YT by deleting stuff after you're done with them. So this del keyword in Python stands for delete. So it can delete ds and you can do a comma delimited list of things you want to delete. And then we're going to import the garbage collection package, import GC, which usually is running behind the scenes, but just want to, I guess, kind of make sure that we're doing garbage collection. And I don't know that this is, I mean, happened after 200 files, so it probably won't happen again here. So we're going to skip to, let's see, 205. So it did 204. So it's going to redo the 204th, but that's okay. So it's 0 indexed. All right, so we're going to try plotting again and try to get all the way to the end. Maybe we'll try to get an MP4 generated this time, since we're kind of waiting on the Rayleigh-Taylor problem to run. So it's about it's about 34% through. So it's moving not too slowly. So while that's running, it can also get like another thing plotting. Okay, we've got a lot of VTK, so I'm going to copy from Orszag Tang our plot.py script. And I'm going to remove this because we want to start from the start. And otherwise, that should be fine. Otherwise, should be good to go. And I'm just trying to think. I think one thing is I'm going to make this. So regarding making the movie, I'm kind of wondering if just the file name format is kind of annoying. So I'm going to switch to enumerating over this list. Oops. So I get what II is, and I also get FN. And then when I'm saving, instead of just doing the default name, I'm going to do string of ii.zfill for plus.png. So in Python, the addition operator concatenates strings. So that means if I do, hi plus do hello plus space plus world, that's going to print the same thing as if I just did one string, which was hello world. So that concatenates them together. And then the .zfill for is saying, okay, now I could have, I could go from 0 up to 10 up to 100 up to, I don't know, maybe 1,000. I don't think I'm going to generate that many files in here. But independent of how many files there are, I want some 0 padding, but there's going to be 4 digits for that, is what I'm telling it. So if it's a single digit number, so if I is 5, then string of ii.zfill 4 is going to go to 1, 2, 3, 5, but it's going to be a string. So the zfill thing is a string method. All right. And so that should be a little bit nicer on the machine to interpret, I think. Hopefully ffmpeg likes that better. All right, so we're going to get that plotting. It's running. It's okay, it's most of the way there now. Now it's like 78% of the way done. Or no, I think it's going to 3.0. So no, never mind. It's a third of 78% done. But this one finished. All right, so this one finished, but unfortunately has, this kind of garbage output. I mean, it's nice because it's telling, in addition to telling the cycle, it mentions the name, which is useful for especially having Orszag Tang versus Rayleigh-Taylor over there. And it's also telling us that we did a slice as opposed to a projection plot. It tells us the axis as well as the variable that we plotted. So it is useful information, but I think ffmpeg shouldn't care, but I wonder if it does. All right, so I'm gonna grab, like in the previous video, I'm gonna grab like a couple of helper things. I'm gonna grab my make even dim script. It's a bash script I wrote like a long time ago. Probably wouldn't do it in bash anymore. I mean, I would use image magic, but I just would wrap it in a Python script like I do with the Animator Script. I still do a lot of stuff in bash. It's kind of fun to do stuff in bash. I used to write like kind of longish bash scripts, but it's just so much easier to do string manipulation and stuff in Python. All right, and then this is runs, and then I'm gonna send that over to Orszag Tang, and then we'll also send the animator on over there, although I'm gonna need to tweak that. Okay, and then we're gonna head on over there again. All right, and then we're gonna, so the issue right now is if I look at one of these PNG files, it has an odd number of pixels along a dimension. ffmpeg hates that. I don't know why ffmpeg cares so much, but in previous experience, it really doesn't like it. So I have this make even dim.bash script, which loops over the all the PNGs in a folder, and then it trims them as needed. So I'm gonna execute this by typing bash make even dim.bash for tab completed, and that's gonna take a moment or two. It's gonna run through all 250 of the files, and I don't have any echo commands, which is the bash equivalent of print, so you can't actually tell whether it's working or not. But if I now do the file command again, then it's an even dimension. If I check the last file, then it's also good. All right, great. And then for this animator script, this is assuming that it's a Flash-like file, which it's not. So I'm globbing for some files, and so I'll, I guess specifically, I don't know if I really want it structured this way per se. I think I'm gonna again just try to do ffmpeg on the command line like I tried to do last video. And we'll give it a go. Right, I guess it's not a bad thing to look at. All right, so this thing's still running. Must be my new tab. And then, oh, okay, interesting. All right, SSH-MPA. We go into Athena stuff. Athena runs Orszag Tang, and then we're going to remember what we were doing. All right, I'm going to type the ffmpeg command in this window, I guess. This is the one where I'll cheat from. So -y -frame rate 30. And then -I, and then the input file name, or I'm just going to try basically copying this. And then instead of this 4-digit thing, mod O4D, and then I need to specify a little bit more. The -pix format. It's going to be 420p, so I guess it's pretty old. Maybe it'd be better as 1080, but there's probably not that many pixels. Okay, and then we're going to call this ot.mp4 like we tried to do last time. Unknown pixel format 420p. YOV 420p. Error while opening encoder for output stream 00. Maybe incorrect parameters such as bit rate, width, or height. So yeah, I think this typically happens when I have, when they're not all even. But I already ran that script, so it should be fine. So I'm just gonna check manually. So file Orszag Tang quadruple 0 PNG. So that one's even. And if if instead of like doing that, if I type in this, I think that this is technically either set or awk. I never really learned either of them except for command substitution. So if this is saying replace, in the previous command, replace quadruple 0 with 0001. And so yeah, those two are good. And so if I make dir images, and then if I cp, and then I'm going to do 000, and then this says like expand this. So it's going to copy both of them. I think this is density.png, and then images, and then look into images, and both of them are there. Great. Oh, well, that's interesting. Oh, I mean, that's correct, but I wanted the 0th one. This one should be good too. So that's okay. I guess I'll just have 3 in this test. I was trying to do it a little bit simpler than what we were trying to do up there. All right, and then -y, -frame rate, 3. So there's only 3 of them. And then I totally forgot -i. And then this thing, except want mod O4D, and then what is it, format? -pix format, YOV 420p. I keep forgetting. And then, yeah, just the name of it after that. So ot.mp4. And that time it worked. Okay. So there's definitely just something messed up. It's probably an error with one of those files from when it did the, probably an error with one of those files from when it terminated from the out of memory issue. So if I do ls-lh, it'll show me the size of the files, and so I want specifically the PNGs. And so they are all a little bit different, but I'm looking for one that's really different, which would have been around 207-ish. And those look fine, so that's annoying as fudge. Bummer. I don't know why it's not really working. So, I mean, what I can try to do, I mean, maybe it's getting confused on something that's not a PNG. So I can copy all these into images, which will take a moment apparently. And then I'm going to try the command again. So this thing worked for 3 files, and now it doesn't work. So I'm going to remove some number of files. So we'll remove, let's look at, so we're going to remove anything with a 1 or a 2. So we're just going to keep the first 100. And then this is a wildcard, which is a single character wildcard. Although I could probably just have done star. I mean, so that's to, yeah, I probably could have just done star. It's kind of safer to not use star to be a little bit more explicit. All right, and then let's try ffmpeg again, and it's still not happy. So try removing everything that is more than 10. So let's say 0, whoops. And then instead of all of the values, we'll remove 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to just keep 0 through 10. That's what this should do. See if I messed up. No, that worked. And we'll do ffmpeg, and that worked. So some dumb file within the first 100 like must be corrupted or something. I don't know why it's giving me this problem right now. All right, well, this thing's done. So so this thing didn't have like that file corruption thing, probably because of the garbage collection, or maybe it just didn't generate as many of them. It generated 154, but yeah, that's fewer. All right, so we're gonna copy make even dim.bash on over here. We're gonna copy, well, I guess we're not really using the Animator Script, we're just using it, typing it in bash. We're gonna make even dim.bash first. And we'll see if we can successfully do this for all of them. Okay, so -y, -frame rate, we'll do 30, so that'd be approximately 5 to 6 second video. And then -i mod o4d dot png -pix format yov 420p, and then we'll call this rt.mp4. Dang. Another issue. I don't know what the problem is, but it says, maybe this is wrong. No. We'll try looking make movie Linux. I prefer Stack Overflow. That's one thing I don't like about, or just any of the Stack Exchanges. That's one thing I don't like about Brave Search, is it doesn't bring Stack Exchange results up as much. All right, so do make images Linux. Super user is probably fine. Maybe we'll just say ffmpeg actually. Oh wait, make movies Linux. Okay, well, Stack Overflow. Well, that's not really what I'm looking for either. So we'll just say like ffmpeg, I don't know, Stack Overflow. Example maybe, I don't know. I don't really need something new. It could be like 20 years old at this point, it would be perfect. Yeah, this is not what I want. I just want a command. All right, well, we'll take a look at this. Linux int. All right. How to install it, check the version. Oh boy. Yeah, maybe I do need a codec, I don't know. Now, all this garbage, why can't it just be simple? Okay. So we'll try that, and otherwise, I don't know. Maybe Athena plus YT is just not as nice as Flash plus YT. 2-RV. I have no idea what this is. I'm guessing that's like a frame rate thing though. Mod. Maybe I need this quoted. I don't think I've been doing it quoted. o4d.png codec v libx 264. So the thing is, I don't know what codec I should, or what libx thing I should use. I don't want the preset though. Pix format stosing yov 420p. CRF I think is a quality thing. I don't know what AN is. And we'll again try rt.mp4, and I guess we'll quote it. And then instead of ffmpeg, we'll do ffmpeg with a command substitution. Yes. Damn it. Yeah, okay. I don't know why I'm having so many problems with ffmpeg, but again, once you have the image files, you can technically do something junky like use a web application to do it, or use anything that you fancied using. Okay, and so see, is Rayleigh-Taylor? Yeah, so this is still not done yet. But okay, well, we generated like a bunch of PNG files. I mean, there's a lot more actually that could generate now. We have 154, so let's go ahead and copy them to the local machine and view them, and then be done with this, because I think this is like an hour-long video at this point, and I need to do some things. All right, so let's go to SCP, receive files, and modify our SCP from bash. And now instead of the binary or bin folder, it's then run/rt startup PNG. We'll copy. So instead of copying them just in here, which is going to get real messy, I'm going to put them in, we'll call it Athena stuff /rt. So I'm going to have to make that first. If I just try running this right now, it's going to say, oh, that doesn't exist. Oh, and so it does end up copying them here. Or no, I think those existed. Yeah, no, those exist previously from the last video. I'm going to remove those because that's really messy looking. And that's better. And I was a little messy here, but that's only, you know, like 5 files. So that's not the biggest deal. So I'm going to make dir, what was it? Athena stuff /rt. And we're going to SCP that again. We're going to open up our Finder. We're going to go over to receive files. We now have Athena stuff. We now have RT. And we've got, oh boy, all this stuff. So, yeah, it probably would have been better to look at that maybe a little bit earlier, because as it would turn out, slicing through the Z dimension is not as, you know, useful for the Rayleigh-Taylor problem. It looks like we want to slice through X or Y instead, one of the shorter axes. So, I'm not going to generate all the files, but we'll do it for at least a couple of them. So I'm just going to call that underscore do the slice through Y. And otherwise, if I didn't add the underscore Y here, it would be overwriting files, which is fine if you do all of them, but since we're just going to do a few or not wait till the end, that would get confusing. Okay, so did at least the first one, did the second one, so that's, I'm not going to wait that much longer. And so I copied the new ones as well as the old ones. It's not the most efficient thing. rsync would probably be better. All right, and so that's what it looks like. I'm used to this being rotated 90 degrees, but it's fine. So in general, you have a denser fluid on top of a less dense fluid with a gravitational acceleration pointing towards the less dense fluid. And so this thing is buoyant, this thing wants to sink, this thing is not buoyant. And so they're going to try to change direction, like positions. And so you can see that there's, and so there's also a perturbation applied. So you can think of there being like a dinner plate separating these two fluids, or just some barrier separating them. And then that barrier is removed forcibly. So if you have like a tablecloth and you have a glass on top, if you remove it really quick, then maybe you have a very slight perturbation. Maybe it shifts the water a little bit, but it doesn't throw the glass. So kind of similar here, you do a very quick sort of removal of the barrier. It applies a small perturbation, and then that perturbation grows with time, which maybe I'll just do one more SCP. So we have a couple. We only have one more of those files. Yeah, it should be up to 25 now. Okay, it just took a moment to populate. But yeah, I mean, it's taking a while for the perturbation to grow. And so eventually you end up mixing this material together, as happens in the cloud crushing problem, where you have a Rayleigh-Taylor instability, which mixes the cold material of the cloud with the hot ambient wind and ends up in destruction of the cloud unless you have efficient radiative cooling, which modifies things. And okay, I think this video has gone on long enough, and hopefully this gives the basic picture. And unfortunately, just ffmpeg is not really working with Athena plus YT I'm not sure what the issue is. There must be some. It might be an issue with my makeEvenDims.bash script where it's not actually making them all even. So there's just some edge case, some file which is not being converted to a even dimension, and that's screwing it all up once ffmpeg gets that file. But maybe I'll figure that out later. Okay, bye.